Hello everyone, this is lecture 2 of module 4 in a series of lectures that I've been delivering to cover the software project management course at the Software Engineering Department, Faculty of Computer and Information Technology, Jordan University of Science and Technology. This lecture will elaborate on the various agile software development methods. Generally speaking, the agile software development methods would involve adaptive planning, evolutionary development, early delivery, and continuous improvement. Now, when it comes to planning, with agile development methods, we always put less emphasis on planning, while we put more emphasis on development. Less time for planning and more time for development, or jump quickly into the development phase. Now, how would that happen? Let's say if we are dealing with an open source, so we don't have to spend a long time trying to figure out the requirements, the design, etc., because we have an open source system from which we can learn a lot of things when it comes to requirements definition and the designs and the layout, the interfaces, etc. So within a very short time, like a matter of a week or two, we can move forward and start adapting that open source system to the way we are looking for, or the way we want, or the customer wants. Now, evolutionary development, it's a very straightforward statement. Evolutionary, be innovative as much as you can as a developer. You are free to develop the system or to rearrange the open source system the way you want. I will judge you based on the deliverables, your deliverables. So we look at the results. We don't look too much at the process, the context of the process, the way we develop things, the way we do things. This leads us to something that we need to mention here. Whoever works with agile software development methods must be an experienced developer or an experienced person. Otherwise, it would be very risky to let juniors to develop software using the agile software development methods. Early delivery, that means we try to deliver things quickly. Also, we may consider the incremental development as an agile method as well, as we will see later on. So the sooner you deliver the ready components, the better for you. Continuous improvement. This has to do with the development methods themselves. We don't stick to the method as is. We try to improve it based on the learning experience. Also, when we develop an agile component, or a software component using agile methods, yes, we developed it quickly and we deployed it quickly, and we made sure that it is working. However, that is not enough. We need to keep an eye on it throughout the development process until we make sure that it's 100% working and it's free of bugs. Okay. Okay, now we talk about the agile software development values. Now, when it comes to agile software development values, we think of 4 perspectives. The values that have to do with individuals, the work in software, the customer collaboration, and the response to change perspectives. Now, in terms of individuals, value-wise must be self-organized and self-motivated to start with. Also, the project team, they must work together. They must be co-located, and they must act as peer programmers or pair programmers, sorry. So they work in the same room, very close to each other. When it comes to an issue, to solving an issue, they work together immediately on it. They don't have to hold phone conferences or video conferences to discuss issues, etc., etc. So communication is the fundamental concept when it comes to agile software development. Now, working software, the value here, first of all, we assess or we evaluate or we judge the agile software development process according to its outcomes, the delivered working components. So whenever you complete a component, just go ahead and deliver it. Just deploy it to the customer and have the customer to use it. So the more working components or the more working software components you deploy, the better results you would get performance-wise. Also, as we mentioned earlier in the previous slide, we put less emphasis on the planning. So part of the planning is the, let's say, the documentation. Don't put too much emphasis on documentation. We need to focus the time on the development. So utilize more and more time for the development, and to resolve the documentation issue, you are allowed as an agile software developer to inline your comments or comments between your code, and later on we can extract those comments into a kind of documentation. Customer collaboration, it's a must. Without the collaboration from the customer, forget it. Your agile software development or agile software project management or agile software work won't work. It will fail. So customer is a keystone in making a project successful, when we use agile software development. Now, a response to change. Now, endorsing change requests and responding to them as fast as possible or as quick as possible is very important. You need to keep the customer in your circles. You need to keep the customer satisfied. Even if you don't have a solution to respond with to the customer, just correspond with the customer and tell them that you received their request for change, and ask for like an extension, time extension, to come up with a reasonable solution for them, and try to come up with a solution as quickly as possible, because that will keep the customer happy and satisfied, and that means the customer will be more and more collaborative with you, and that means your agile software development process will be good, will be successful. Now let's talk about agile software development methods, principles. Here we look at 12 principles. The first one, the main principle, is customer satisfaction, and we talked about earlier when we talked about the values that customer collaboration is very important. You cannot encourage customer to collaborate with you unless they are very satisfied. And one way to satisfy the customer is to make early and continuous delivery of working software components. Changing requirements. You need to welcome any change request that comes from the customer and act according to them. Working software is delivered frequently. Do not leave the customer out of the picture. Every time you develop a component, complete a component, just deploy it, deliver it to the customer. Make sure you don't wait for long. Make your software into small components so you can keep on delivering them from time to time, like on daily basis, on weekly basis, etc., etc. Cooperation, both the customer and you as a service provider must be in a very good shape cooperation wise. The individuals who work on your project must be motivated, must be outgoing, must be very interested in doing the work. You don't need to push people to do work when it comes to agile software development methods. They must feel the ownership of the project. They must feel the ownership and the honor to do the work they are doing. Face-to-face conversation. We mentioned earlier the co-location and the pair programming. Here, when it comes to discussing an issue, it's better to have it a face-to-face discussion rather than remotely. We look at working software is the primary measure of progress. So the more components you deliver, the better impression you leave with the customer, and the better performance result you get. Sustainable development. It's not a one-time shot. You need to develop the component, deploy it, keep an eye on it, and you may come back to it and improve it, etc., etc. Continuous attention to technical excellence and good design. Well, with agile software development, we recycle or we reuse some concepts from or some designs or some architectures so that were used before, or we learn from others. So in that case, we need to keep an eye on the latest updates and the various aspects that have to do with software, the technical excellence, the designs, the architectures, etc., etc. Simplicity. Keep things as much simple as possible. Documentation-wise, design-wise, code-wise, interface-wise, layout-wise, database design-wise, keep things easy because it's not only you. Someone will come after you and they need to understand what you did, and they need to be able to carry on what you did in case they want to make changes or they want to support the work you delivered. Again here, best architectures, requirements, and design try to be to come up with the best. Look at what are the possibilities, what are the alternatives, and choose the best alternative for architecture, for the design. And even when you define requirements, try to come up with reasonable and decent requirements. Last but not least, regularity. You need to keep doing things over and over, doing them the right way. When you use a method, stick to it for some time until it becomes mature. When you deliver components, keep an eye on them, as we said, on regular basis. Let's say every week you revisit all what you developed and try to enhance them or double check things, etc., etc. So that's all for the In this slide, we'll go over some of the agile software development methods. We look at the adaptive software development method, the agile modeling method, the agile unified process method, and the disciplined agile delivery method. The first one, the adaptive software development method, is very much like the RAD, the Rapid Application Development methodology that we explained in details in one of the lectures of Module 1. The Agile Modeling, it's a method for modeling and documenting software systems based on what? Based on the best practices in the field. In comparison to the traditional modeling methods, it's considered more flexible, and also it fits in fast-changing environments. The third one, the Agile Unified Process, It's a simplified version of the Rational Unified Process, the RUP, the RAP. It's an approach to develop business software using agile techniques. It uses the various agile techniques such as test-driven development, agile modeling, and agile change management. And the purpose behind using such techniques is very much to improve the productivity. The fourth one, the disciplined agile delivery, it's a process that enables simplify the process decisions around the incremental and iterative solutions delivery. And we talked about the incremental and iterative project management methodology. We talked about the incremental and iterative software development approach, etc. Is very much here a simplified version of that to speed up the process from the agility perspective. Okay, now we continue with the agile software development methods. We look at 5 more methods. Feature-driven development, a lean software development method, Kanban, and Scrum, and Scrumman. Let's go over them one by one. The feature-driven development method, it's very much an iterative and incremental agile software development process where software features are driven from the customer required or needed functionalities and requirements from all types, like functional, non-functional, etc., etc. And the purpose behind this feature-driven development method is to deliver working software repeatedly in a timely manner. The lean software development method is very much a translation of the lean manufacturing principles, which we explained and elaborated on when we discussed the lean project management approach in module 1. So it's translation of that to the software development domain. In other words, using the same principles that were used for lean manufacturing, using these principles or translating them into the software development domain. The Kanban, this method aims at managing work by balancing the demands with the available capacity, as well as to obtain or to get a better handling of the system level bottlenecks. Kanban can be used for software development domain as well. Scrum is a framework for managing software development, as simple as that. Teams are designed of small people, to consist of small people, and their work is broken into actions that can be completed within fixed cycles. We call them sprints or scrums, and to track progress as well as to collaborate to deliver working software every sprint or with every sprint. Now, Scrum can be used in large firms, and in large firms we would find large-scale Scrum, scale agile frameworks, and Scrum of Scrums. The Scrumban, it's a hybrid of the Kanban and the Scrum. Very simple. The last 2 methods that we are covering in this module two methods of software agile development that we are covering in this module are the dynamic systems development method and the extreme programming method. The dynamic system development method, as we can see from the diagram here, it starts with the a feasibility study and establishing the foundation. That's after we start the project. So we have the pre-project phase, then the project phase starts with feasibility and a study and the foundations, establishing the foundations. Then it moves to the next step for exploration, like researching the problem, etc., and defining the requirements and so forth, the specifications. Then it moves to the engineering, where we design the system, etc., and then we move to the incremental development, where we go back and forth with the engineering. The extreme programming, it's another methodology, as you can see from this chart or this graph. Things start with the release plan, then it moves to the iteration plan, acceptance test, stand up meeting, peer negotiation, unit testing, and then pair programming and code. And from the code, we can go to any of the previous steps or stages. So if the code is all right, then we move straight to the release plan. Otherwise, if there is an issue, so all depends on the nature of the issue or the problem that we found with the code. Either we need to go back to the pair programming and discuss the issue within the team. If that is solvable, that's fine. Then we close on things. Otherwise, we go back to unit tests or pair negotiation, etc., etc. So very much as you see, there are many iterations here. And the nature of the problem that we find out in the code when it comes to release it. So the size of the problem, the nature of it, decides or helps us decide where to go back. Go back to the iteration plan, go back to the acceptance test, the stand-up meeting, the pair negotiation, unit test, pair programming, and so forth. For example, if the issue or the problem is really serious, then we better go back all the way to the beginning, the iteration plan, and reconsider the design, reconsider the definition of the requirements, etc., etc. If it's a bit less, then we may go back to the acceptance test stage, and so on. Now, in this slide, we'll talk about agile software development practices. The first thing is the agile modeling. We talked about this earlier. Agile testing, similar to the agile software development, agile software modeling, agile project management, there is agile testing. There is agile design. So agility is almost everywhere around the software engineering knowledge areas. Backlogs is where we store the results of the test cases when we run the tests. Iterative and incremental development, we spoke about this. Behavior-driven development. Now, the best example on this is the Facebook. When you are on the Facebook, you like a page, you just click like for a page or for a post. The Next time you log into Facebook, you will find similar posts or from the same page or from similar pages are being displayed on your page on the Facebook. So what happened? Facebook captured your behavior, your interests, etc., and started to feed you in with things that you like. Test-driven development. Throughout the development process, you test the component that you have in hands. If it works fine, you move forward. Otherwise, you go back and fix the issues with that component before moving forward. Domain-driven design. Again, this has to do with the business domain or the type of the business you are dealing with. For example, if you are implementing an email server in the education for a university, like the education domain, versus deploying or implementing the same system for a security or intelligence department, for example. Now, the design decision as to where to place the server, should it be in my place, or I can host it like on the cloud. So it's either a local hosting or a cloud hosting. So with the education, it won't make any difference for them. The cloud hosting might be cheaper on them, so they would prefer to go with the cloud. While with the intelligence, they say no, the information are too much sensitive and we cannot allow cloud hosting. So they will go with a local server hosting. Story-driven modeling. Again, I think you can see that on the Facebook. There is a story where you post your stories, etc. Continuous integration. We talked about this with the scrums and the sprints, where we break down things into the system into iterations. We go all the way to the lowest level, so it's a continuous breakout. Then once you develop the small pieces, you integrate them together into higher level components. Then those components, integrate them again into higher components, etc., until you get back to the highest level. So it's breakdown, a continuous breakdown, and then continuous integration up. The information radiators. We know what the word radiator means. Radiator, like the air conditioning, it radiates the heat, the cold air, etc. Here, instead of radiating the heat, we radiate information. As simple as that. It's the same the same sense here. So you may have a task board, it's a radiator. You may have a visual management board or a burn down chart. Okay. Business analyst designer method. So the business analyst and the designer would be the same person in this case to speed up the process, and that's one of the objectives of the agile software development methods. Cross-functional teams, because things are going in a hurry, things are going in parallel. So for the same task, you may involve people in the iteration to carry on something from all functions, from the development, from the testing, from the analysis, etc., the planning, etc. Co-location and pair programming. We talked about this earlier. The co-location and pair programming. You need your people, your team, to be working in the same room or the same building, so they will have easy access to each other if something or an issue breaks out. It will be very fast, very quick for them to meet and resolve that issue. Well, that's all for lecture 2, and I will be looking forward to meeting with you at lecture 3. Thank you for listening to me.